Hi guys, Daniel. I'm part of NAILUG, and yeah, it's so glad to see some new faces. And also see some old ones. No. All I say, you're part of NAILUG. Any better than NAILUG. So as that's being set up, I think I can start with how I got interested in HTTP and TCP. But I'm not networking in general. So it's a learning project for me. So if there's anyone in the audience who knows a bit more or can contribute, you're welcome to do so. So I believe the best way to learn something is simply building it from scratch, right? Because theory can only take you so far. Theory can only take you so far. But at the end of the day, you need to get hands-on, you need to actually work with the technology. So, I think I'll start with some history, a brief history of
What's up?
A brief history of TCP. Sorry, not TCP, HTTP. So, TCP started out in 1996. How many of you are familiar with Tim Berners-Lee? Right? You're familiar with Tim Berners-Lee? Yeah, the guy who invented the web. What he did is he invented HTTP 1.0, right? And all he did was just static text. It's a GET request with some quick information, and that's all it does, right? Just sending and receiving text. Now the bottleneck was that TCP required a three-way handshake to establish a connection. This was very inefficient. It caused massive latency. Moving on to HTTP 1.1. During this era, actually, what used to happen is there used to be a lot of dark type solutions. So there used to be a lot of pseudo protocols that came out, and at some point there needed to be a consensus on all these protocols being brought together, right? Because at the end of the day, HTTP 1 was 1.0, that is, was very efficient. Moving on to 1.1, and this is when people convened and they were like, hey guys, we need to create something better. And this is the protocol that we actually going to implement today. What it did is it introduced persistent connections, that is, keep alive connections. Instead of closing the TCP pipeline after one file, once you get the pipe open, it said subsequent requests down the same connection. Although this had a problem, it suffered from end-of-line blocking because requests still had to be processed sequentially. This is actually the protocol we use commonly today, HTTP 1.1. It works amazingly for a lot of common use cases today. But there are some use cases where it doesn't necessarily work quite well. Next is HTTP 2. So, I think you can't throw shade on HTTP 1.1 because it worked well. Between 1997 and 2015, people were okay with it, right? Because it worked that well, it lived for about, that's how many years? 18 years without being revised. Of course, there were issues coming up, but they wanted that pertinent that people learned to convene and actually create a new protocol all the way up to 2015. This is when a multiplexer protocol was created, that is HTTP 2. Stopped using plain text strings and switched to a binary framing layer. This allowed multiplexing. So the server could slice up multiple files into thin binary frames and send them on concurrently down one TCP connection. And they were reassembled on the browser side. The difference between HTTP 1 and HTTP 2 1.1 that is in HTTP2 is that in HTTP1, one TCP connection was connected to one HTTP connection, right? So only one HTTP message will be sent down one TCP connection. But in HTTP2, what you do is you take many HTTP messages, you break them down into whatever chunks are needed, whatever size chunks are needed, and you send them through one TCP connection. And what does that do? This solves this solves a problem whereby one TCP connection is not blocked, right? Because in HTTP 1.1, you have one TCP connection being lazy. Because imagine if on the server side, maybe there's some processing happening. That's one TCP connection being held. And it's being held stagnant, it's not doing anything. And these are opening a TCP connection is very expensive because what you're doing is you're calling a system called the operating system. You're telling the operating system to do a bunch of things, right? There's queuing setup, there's a lot of resources being held on the operating system side that are very expensive, and having one HTTP message, all that is very efficient. So HTTP3, what HTTP3 does, and these are very young, it's a very recent protocol, it just teaches TCP altogether. Maybe to take you back to the website model. So you start from the physical layer, you go there to the application layer. Just below the application layer, that's where you have TCP and HTTP. Sorry, TCP. And there's another one called UDP. The difference is UDP is more of a chaotic kind of protocol. No, it's just sending packets. It doesn't really care whether they've reached. But with TCP, there has to be a confirmation from both sides. So if I send a packet, I listen on the other side. Has it reached? It's reached. Okay, now I can send the next, the next, the next. Now, the thing about TCP is it trades off that clarity, right? That clarity to know that a packet has reached for speed, because it has to do a three-way handshake. Right? It has to send, listen, then send. So it has to kind of trade off speed for that clarity. But with UDP, it's just send. So it's very fast, yes, but it's very chaotic. That's what I like to use, chaotic. Sorry? Are you sure? Which one has the three-way handshake? Are you sure? Can I get a second opinion? Again, you mentioned this a learning exercise even for me, not an expert, so you can get a second opinion that would be good. Sure.
I think the way you were saying is correct.
So TCP is the three-way handshake, there is clarity.
Then in UDP, it's just send as well. It's used mostly in like streaming.
Yeah.
But now for TCP, it has to have a three-way handshake. The send an acknowledgement from has to receive.
Yeah. So so there are some pragmatic outcomes. The first thing is independent streams. Because UDP doesn't care about packet order, QUIC handles the ordering itself per stream basis. If an image packet is lost, only that image packet pauses, the CSS and JS streams keep flowing uninterrupted. Zero round trip time. QUIC brings TLS encryption directly to the protocol, combining the network handshake and the security handshake into one step, rapidly speeding up connection times. Finally, this is important. familiar with Rust, it's
Nice.
it's a very complex program I've written, so I think it's very self-explanatory with the variable names and such. So in this program, there are 4 parts. First thing is the TCP layer. We have to connect to the TCP. You know that we have to set up a connection. We have to kind of reserve a port TCP so that you can be able to send and receive packets. Part 2 is passing the request. Now, one thing I want to mention, and this is actually a very important point, is HTTP is an application layer protocol. So essentially, you, the programmer, are the one implementing HTTP. Whenever you're using Django, whenever you're using backend frameworks are there. .NET, another backend framework. Laravel, another backend framework. Django, Spring Boot, Java. So the thing with these backend frameworks is they're the ones implementing HTTP. Either that or the language's standard library is the one implementing HTTP. That's why it's called an application layer protocol, because you, the programmer, are the one implementing HTTP, right? And as you know with frameworks, is they're kind of a lazy way to, not lazy necessarily, but a kind of a lazy way to, right? You can never write your HTML, you can just use React with all the opinions and all the easy work being done for you. So essentially, that's what HTTP. That's what HTTP is. It's an application layer protocol. Unlike TCP, which is implemented at the OS layer, right? So when you're connecting to TCP, you are making system calls to the operating system. That's why it's very expensive, right? That's why going back to what was it? HTTP 1.1, moving on to HTTP 2. That's why there was that shift, because they noticed this one TCP connection is being held by this one HTTP message. It doesn't make sense, it's very inefficient. So, part 2, that is, you pass the request. This is the important part. This is what ties into HTTP being an application layer. What you're receiving from TCP is just a couple of bytes. TCP doesn't care. So you're just receiving bytes. So it's for you to take those bytes, process them, right? Actually, first of all, convert them into string, and then process them. That's when the passing happens. And then you grab the request, right? Because in the HTTP message, there's going to be a route specified. So that's where the routing the request happens. And then the server now brings the response as dictated by the programmer themselves. I've separated them into a couple of functions here. So I think we can start with the TCP then. And that is setting up a function to TCP. Now, this part, you can see this. Let me start with explaining the general execution of a Rust program. There's a main function, just like any other. The main function is the entry point to the program, right? That's where we started. This is the code that's being executed. This coding name, right? We have a function here. We are maintaining a variable, and we are binding the TCP port, right? And what that TCP listener bind is doing, don't worry too much about the syntax. You can just try and going about it like it is English, okay? Just, if there's any ambiguity, please ask me to just to see where the sensible with that. Please ask me to clarify. So, what TCP listener bind is doing is the OS, is that port occupied by any other program? Then the OS comes and tells it, yes it is. If so, then the program ends. And error is thrown essentially. Then what this app does is it sends two responses, right? There's a response whereby it's telling me, okay, you're okay to go. And then the response is an error, right? So for the okay response is whereby the port is open. So it comes to me and tells me, okay, the port is open, you're fine. But if not, it's going to throw an error and the program is going to crash essentially. Then the next thing we do is, now after we've opened up the port, is it opened up the port? After we've owned the port, after this program has owned the port, the OS is going to cross a bunch of packets, right? That's what the for loop is doing. It's just constantly reading that. It's just constantly reading those packets. And in Rust, a for loop is a while loop that automatically calls an iterator. What does that even mean? An iterator is something that's constantly throwing new things, right? So just constantly throwing new things. How the for loop is doing, it's catching those things, right? So you can think of it just like a while loop. It's a while loop essentially, whereby while true, you can think of it that while true, you catches those packets until of course the program is manually stored. So what are we doing that for? We are catching a bunch of strings. Those strings are essentially those packets, right? And when we catch a string, we are handling each string, right? We are handling each packet. Okay, how are we handling those packets? We are handling them using the handle connection function. Okay, it is Apache. Sure. Sorry? Unwrap. So in Rust, unwrap, so this string is returning me something called a result. There's something in Rust, that's how we handle errors, right? Because you're not sure whether a string, like it's corrupted or something of the sort, anything can be happening with it. So if there's an error, it's just going to return the error and crash the program. Because I'm not handling, we're supposed to handle it in a certain way. It's supposed to be kind of an if else statement, whereby you say if error do this, and then else continue nicely. Okay. So because I didn't want to overcomplicate the program, I need to handle it. So unwrap, that's just all unwrap does in Rust. Yes. Yes. Yeah, I'm not handling it. Yeah, this terrible code. It's just simple code by the way. It's not supposed to be graceful anyway. It's just supposed to bring out the code. So in the handle connection function, what are we doing? Sure.
The main function. We talked about TCP and HTTP. I would like to understand if that function is only opening TCP connections or HTTP connection or both.
So, what you are doing, as I mentioned earlier, HTTP is an application level protocol. I'm the one everywhere. HTTP is being handled by you, the program, either directly, right, as we are doing right now, or indirectly through either a standard library inside the programming language, or through a framework. Yeah, exactly, like internet, something of the sort. Exactly. Right? So at the end of the day, it's you the programmer handling it. but TCP is implemented at the OS level, right? So you can't really on TCP, but generally it's not. You can also build your own loader and build your own OS, but once you do that, right, it's too much work. It's like overkill, right? So what we are doing, we are opening a connection to TCP, and we are getting those packets, and we are receiving those packets. We've kind of gone to this port, 78, we've owned it. Now it's ours to do what we want with, right? To receive packets and to push packets. Does that answer it?
Yes, it does. On the ports.
On the
Ports. Can one just get a number to hold as a port, or the specific numbers for the ports?
Yes, they are specific. At the end of the day, these things are protocols. It's things that have been agreed with. But yes, there are certain ports that have been reserved for certain functions, right? Like I think port 80 is for, I'm not sure. I think it's for HTTP port, like React using port 3000, right? And I'm sure there are a bunch of other ports that have been reserved. I didn't go that much deep into that. But I think how many ports are available? It's a binary number. 0 to 64? Yeah, something. It's 0 to 2 to the power something. Yeah, because computers in binary.
Going to the first 1024, from 0 to 1024 is out to the root user, because these ones are tied to the core protocols that you govern the internet SSH, HTTP, HTTPS. So it's only from 1025 to 65,000 and something that are available for development and other users.
Yeah, so I hope that answers your question. Yeah. So on to the handle connection function. Let link buffer. So let is just the way normally, it's even in JavaScript, right? That's how we normally declare functions. Sorry, variables. Mute, the thing with Rust is all variables are immutable by default. That's kind of weird, but all variables are immutable by default. So for you to be able to change a variable, you have to explicitly declare it using the mute keyword. So what you're doing is you're declaring a buffer, and that buffer is mutable because we want to add and remove data from it. And then we read the string, right? The string we received up there. We read it and append it to that buffer. There's an unwrap there which handles the error, not gracefully, unwraps it. I don't want to get into that. And then we declare the request text variable. Now what we're doing here is we are converting those bytes from those raw bytes we received from string to a string. Now we will not manually read the bytes, but that's overkill for this session. You could actually do it manually. And I think I'll give that away again. Now what we're doing is we're not converting that string directly from string itself. So we are not converting those bytes to string directly from the string. We are converting it from buffer. And the reason why we're using buffer is because we can't keep on making calls to, as I told you, TCP calls are very expensive because essentially voice calls. We can't keep on making calls to the OS. So what we're doing is we're taking that string and we're putting it in our own buffer. right? Whereby once the buffer is occupied, now we are reading those, we are converting those bytes to string. The next thing we do is we pass the request using the pass request function. Let's jump to pass request. It's right here. I think I will do split. Split to us. This side, it's just the same file. Just I'm giving you two perspectives so that you can get able to kind of, because we're jumping through functions here. This is the pass request function, right? You can see it returns a method and a route. Now, what does the pass request do? Pass request is essentially, so you know how JSON works, right? JSON is just a specification, right? So it's someone sat down and said, when you see a bracket, a square bracket, you assume this is a list. This is essentially a list. So that's what pass request does. It's just taking that string, it's just passing it according to the rules of HTTP, how HTTP has been defined. And in HTTP, the first line always looks like this. So what this first request function is doing, it's just looking for the method, the HTTP method. That should be the first set of characters. If not, then that HTTP request is malformed and can't move forward with it. The next one is the route. The URL is essentially the URL in the browser, www.google.com/. Now that slash is the route we're using to access that domain. And then, of course, the method. That's the first line of what HTTP strings, HTTP text should look like. After repeating that, we extract the method, the route, and then print it to the terminal. Then next, we go to this side, part 3, you route the request. So you have to route the request to a certain route you define in yourself. That is, let's say you typed facebook.com/profile. Now that /profile, that's the route. And then you build the response. Of course, you received a request, you have to give a response back to whoever sent you that request. And then the response you're giving, since you received it in byte form, you have to give it back in byte form. So you have to convert it back to bytes, and then push it to the TCP connection that you want. Sorry, the port, that TCP connection you want. And then, yeah, that's pretty much it. Let's run the server and see what comes up. No problem, yes, it's on energy, so it's going to be a very interesting course. Yeah, so those are some very nice resources you can use. At the end of the day, the technologies we use, they aren't as complicated as you think they are, right? At the end of the day, it's someone else who built it, and you can build your own. When I began this talk, I mentioned that the best way to learn something is to build it from scratch. No matter what it is, no matter how intimidating it seems, the best way to learn is just build something from scratch. And yeah, I learned a lot from this project. I learned how the operating system works. I'd actually done something a bit more complicated, but I decided not to present that. I decided to present this just to make it more accessible. Yeah, so that's TCP. I hope you found it interesting, just as I did. And yeah, if you have any questions, I'm over there. Thank you.